So this is part 2 of that question. I found the distance from PQ is the square root of 8.5. I don't need to work it out as a decimal as 2.9, but you can. And the distance from RS is also 8.5. So I found that those two are the same. I'm now going to check to see if the distance of PQ or RS is the same, or it's actually enough to do just to check the gradients. If the gradients of PQ and the gradients of RS are the same, they will be parallel. Yes, I think we need to check the distance as well. So let's do the gradient of PQ and the gradient of RS. So I write down very clearly what I'm doing at each step. So I'm doing the gradient of PQ, which is y2 over y1. So there's y2 minus y1. Gradients we subtract over x2, x1, 3 minus a half. Work out what that is. Do the same for the gradient of RS. We did PQ. So this gradient of RS would be the same. I'll write it under there. See what we get, and we'll check in a second. Right, so it's clearly shown that the gradient of PQ is equal to 3/5 there, and the gradient of RS is also equal to 3/5, so the gradients are the same. We found that the lengths are the same, so we know that those two are parallel, the same length. So we could conclude that the other two, joining the points, would also be parallel and the same length. We can test it. I'm going to show the working for QR and PS, the distance and the gradient. We can check it and write a conclusion, and that will give us enough for achieved level. So here I've shown the gradients are the same for both QR, negative a half, and PS, negative a half. The distance are the same, square root of 11.25. Therefore, we have a quadrilateral. It's actually a parallelogram. So we have a parallelogram because the sides are the same and the equations are the same. So write a little conclusion about that, and then you're done. So here's my final conclusion. PQRS is a parallelogram. It has pairs of sides that are parallel and equal lengths. Here's my conclusion, done for achieved level.